Hello. When I was thinking about what I could involve in Halloween bundle, I was trying to think of things which were fairly basic for younger children, things which were a bit more complex for older primary school children. And it struck me that 31, October the 31st, is a prime number. So I thought, well, why not introduce prime numbers? Because it's something that um, children are introduced to at the end of primary school, and then it's reintroduced again at the beginning of secondary school. So what I've done is I've popped this in there as a grid. It covers two sheets. The first one has the instructions how to fill it in. The second one also has the answers. But what you do, I'll give you a quick run through, is prime numbers are numbers which only have two factors. And a factor is a number which will go into another number without leaving a decimal. So, for example, let's see, 4 is a factor of 8 because 4 times 2 is 8. So you would find, so 4, yeah, is basically a factor of 8. So what we need to do is the first one we need to do is cover up number 1 because 1 only has one factor and that's 1 in itself. The only times table you're going to find 1 in is the one times table. The next ones that you'll cover up is don't cover in colour in number 2 because that is prime, because the only times table you'll find 2 in is the ones in the 2 times table. So that makes it prime. But any other even number can be divided by 2, which means it's not prime. So you can colour in all of these columns. Sorry, let's try again at that one and that one. So there, now we've coloured in everything that's even and could be divided by 2. Again, we're not going to colour in number 3 because the only times table you'll find 3 in is the 3 times table, but we can colour in all the multiples of 3. So 3, 6 is done, 9, 12 is gone, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, sorry, 57, 60's gone, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. Okay, so that's the 3 times table now coloured in. We don't need to worry about the 4 times tables because when we did the 2 times tables, we inadvertently did the 4 times tables as well. So the next one we need to do is the 5 times table. So again, we're not going to colour in number 5 because the only times table that you'll find 5 in is the ones in the 5 times tables. However, all these other numbers that finish with a 5 can be coloured in. So if it ended in a 5 or a 0, we would colour it in for the 5 times table. Okay. The 6s we did when we did the 3s. So the next ones we need to do are the 7s. So 7, 14, most of these will probably be gone by now. 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, 98. Okay, so that's the 7 times tables done. Again, we did the 8s when we completed the 2s because you would find if it's divisible by 8, that means it's also got to be divisible by 4 and 2 because they're just a smaller version of the same thing. We did the 9s when we did the 3s. A quick cheat for the 3 times table. If we have a number such as, let's go 36. I'm kind of thinking, does that go into the 3 times table? Yes, because if we do 3 plus 6 equals 9, and 9 is in the 3 times table. Let's go 216. Let's try something harder. 216. Is that a multiple of 3? Yes, it is, because 2 plus 1 is 3, 6 plus 3 is 9. So again, it's going to be in 3 times table. Let's try another one. Let's try something that's not going to be a multiple of 3. Let's try 215. 2 plus 1 is 3, plus 5 equals 8. So you wouldn't find 215 in the 3 times table. It's just a quick and easy cheat. So if you're not sure whether something is divisible by 3, that's just an easy way of finding out. And finally, the 10 times table, we completed that when we did the 5 times table. So all the numbers which are left in white are prime numbers. So, and if you're a member of the Clara James approach, there are some more activities in there associated with prime numbers. Okay.